in this question, we are given with a reaction that is A goes into B plus C and the initial concentration of A is given to be 0.01 molar. And it is also given that after 100 seconds, the concentration of A becomes 0.001 molar, and we are also given that the rate constant has a value 9, and we have to find the order of the reaction using this above data.
Okay, the reaction is A plus A goes to B plus C, which and at time t is equal to 0, concentration of A is 0.01.
Yes.
And at time t is equals to 100 seconds, concentration of this is 0.001.
Yes.
And rate constant K is equals to 9. So
using the data, we have to find the order.
Okay. Now अब हम क्या करेंगे कि concentration initially ये से ये वेरी कर रही है, इसका मतलब कि पहले अपन assume कर लेते हैं ज़ीरो ऑर्डर है कि नहीं है, वो अपन वैल्यूज चेक करके बता देंगे. अब इसके लिए x ज़ीरो ऑर्डर के लिए इक्वेशन है, इंटीग्रेटेड इक्वेशन है x इज इक्वल्स टू kt. सो x होगा इसके लिए 0.001 minus 0.001, which is equals to 9 multiplied by 100. Clearly these are not equal, therefore this reaction is not a zero order reaction,
because the integrated rate law for zero order reaction is not being satisfied.
Okay, so let us assume that this is a first order reaction, and for first order reaction x is equals to 1 by t, k is equals to 1 by t ln of a upon a minus x.
Yes.
By putting the values, k is equals to 9, 1 upon 100, ln of a is equals to
0.01,
and a minus x is equals to 0.001. This is also not satisfying.
Yes.
Therefore, it is not a first order reaction. So now let us assume that this is a second order reaction. Therefore, k is equals to 1 by t plus, kt is equals to 1 upon a naught 1 upon at minus, by putting the values, k is equals to 9 multiplied by 100 is equals to 1 upon at, which is equals to 1 upon 0.001 minus 1 upon 0.01, which is further equals to 900 is equals to 1000 minus 100,
which is true.
Therefore this
reaction is a second order reaction.
Okay.
And can you please write this equation more clearly?
Yes. K multiplied by t is equals to 1 upon at minus 1 upon a naught.
Okay, thanks. So in this question, we first assumed, in order to find the order, we first assumed that the order was 0, but the equation was not satisfying. Then we assumed that it was first order reaction, but it was not so. And the integrated rate law for second order was satisfying with the given data. So it was a second order reaction. Okay, so in this question, we have to find that how our rate constant, that is K, will change if we add a catalyst to the reaction. Note that catalyst will decrease the activation energy of the reaction. And in this case, it is given that the activation energy will be decreased by an amount 10 kilojoules per mole.
So the final activation energy will become EA dash is equals to EA initial activation energy minus 10,000, as it is in kilojoules.
Okay.
So Arrhenius equation is K is equals to A e raised to the power minus EA by RT.
Okay.
And finally K dash will become A multiplied by e raised to the power minus EA dash, which is further equals to EA minus 10,000
by RT.
And the value of R is 8.314 and the value of T is 127 plus 270. 273, which is equals to
400 kelvins.
exactly. Therefore, K dash is equals to A multiplied by e raised to the power minus EA by RT multiplied by e raised to the power 10,000
by RT.
by 8.314 multiplied by 400.
Okay, we can replace A into e to the power minus RT by K, which was our initial rate constant.
Exactly, this is our initial rate constant. Therefore, K dash is equals to K multiplied by the value of this comes out to be 20. Therefore, K dash is equals to 20 times initial K.
So if we add the catalyst, our rate will increase by 20 times. In this question, we applied only the Arrhenius equation to solve this, to get to the answer. Okay, so now let's solve this previous IIT question which came in year 2007, in which you have to find the order of the reaction. We are given with this reaction A times G plus B times H goes into products, and we are also given that if both the concentration of G and H are doubled, the order of the rate of the reaction become 8 times, and however if only G is doubled, keeping the concentration of S as constant, the rate of the reaction is doubled. Using this information, we have to comment on the order of the reaction.
So, as we can write, rate is equals to K multiplied by G raised multiplied by H raised to the power Y.
Okay.
So
we are assuming the powers to be X and Y.
Yes. So rate becomes 8 times when G is doubled and H is doubled.
Okay.
So by solving this, 8 times rate is equals to K multiplied by G raised to the power X multiplied by H raised to the power Y.
And 2 to the power X plus Y.
2 to the power X plus Y, exactly. So this is initial rate. So 8 times rate
is
is equals to 2 raised to the power X plus Y times
rate. Because we can write K into G to the power X and H to the power Y as initial rate.
Therefore 8 is equals to 2 raised to the power X plus Y. So X plus Y is equals to 3.
As 2 to the power 3 is 8.
And X plus Y is also equals to overall order. Therefore the answer is 3.
Okay.